Okay, so this is the application problem for Module 5, Lesson 1. So what you're going to need is an index card, a pen, and a pair of scissors, and a ruler if you want, but you don't necessarily need it. I didn't use it. So the first thing you're going to need to do once you get these items is you're going to need to draw diagonal lines from corner to corner and corner to corner. So pause now and do that real quick. Okay, so now that you've done that, we have divided this rectangle into 4 different parts. So we might think that, well, this means we have 1/4, 1/4, 1/4, and 1/4. But you can't have fractions unless it's divided into equal parts. So did we make equal parts? That's the question we need to answer today. So go ahead and type in whether or not you think we made equal parts. Okay, so now we're going to try and figure out how to figure this out. First step we're going to do is we're going to use our scissors and we're going to cut along these diagonal lines to cut this out. So let's do that real quick. Okay, so now that you've cut those out, you should have two sort of like isosceles looking rectangles or triangles, and then two sort of equilateral looking triangles. So now do these two triangles look like they have the same area? Go ahead and type in whether or not you think they look like they have the same area. Okay, well, how can we possibly figure out if they do have the same area, if they are equal to each other? Well, one way we could do it is that we know that if we cut a fourth into two parts, it should give us an eighth. So if you had go ahead and put in our rectangle here, and you can fill out the other part. It goes right here. It's not perfect, sorry guys. But if you had this and you went in half and divided it again, you would go from fourths to eighths. So what if we, instead of cutting them, we could just go ahead and fold them? So let's fold them in half, because if you fold a fourth in half, you should get an eighth, right? So it just makes a smaller one. Well, I did this with one of the equilateral looking triangles, so now I'm going to do it with one of the like isosceles looking triangles. So I'm going to divide this in half. And again, these aren't going to be perfect unless you did this with a ruler and you're just really patient. I'm not. So it's not going to be perfect, but it should give us a general idea. So now I have 2/8. Let's see if we line them up if they're roughly the same size. And yeah, they are. So when we unfold them, this shows that half of this is equal to half of this. So even though they're not distributed the same way, they still are actually equal to each other. They still do have the same equal area. So it's pretty neat. And that's the end of that problem. So good job.